Hello and welcome to this podcast. My name is Armin Beck and I am product manager of this product. The next couple of minutes I'm gonna lead you through this commissioning example video. Before I start with the example, I want to show you what the requirements are that you are able to follow this podcast. First, you need to install the software package on the DVD that comes along with the device. Then of course you need a physical netTAP 50 device and connect it to your local Ethernet network. I have a netTAP 50 RSEN device right in front of me and I'm gonna show you a Modbus TCP to Ascii conversion. As tools, I'm using Windows Hyper-Terminal and ModScan 32. For quick launch, I placed all the utility icons on my desktop already. The upper two ones you usually find down here when you make the DVD installation. Since a netTAP 50 device has an IP address of 0 when it leaves a Hilcher, we have to scan for this device first. For this, use the Ethernet device setup utility and press scan. It scans for all Hilcher devices that are connected to the local network. In my case, it finds 2 of them. The upper one is my netTAP 50. With a right mouse click to it, I'm setting now a valid IP address. So, just another scan to look if it has been really set. Yes. Okay, now we can start Ascii.net configuration utility. When you start Ascii.net the first time, you see in the middle of the screen a gray bus line. To this bus line you drag and drop your devices. In our specific case, we have to drag and drop the netTAP 50 device to it. Here's the bus line. To the right hand side you see the device catalog from where we now pick and place the netTAP 50. Open Modbus, Gateway and netTAP 50. And here it is. A double click opens the configuration window. Since this is a new Ascii.net installation, we need to set up the driver first. Click on NetX driver and TCP, and with a plus you add a specific IP address or a range of it that will be scanned later for devices. In my case here, I'm just specifying a discrete IP address. Going back to the device assignment page, and a scan will bring up my netTAP 50 to life. Make a cross check here and press apply, and the assignment is finished. As next, we have to choose the primary and secondary network that we intend to use. In my specific case, this is ASCII to Modbus TCP. Based on these two settings, Ascii offers you the correct firmware. This firmware has to be downloaded to netTAP, since every netTAP that leaves Hilcher comes without any firmware loaded. A firmware download deletes the whole configuration in netTAP, and it also forgets the IP address that has been set before. This is why Ascii.net will lose the connection to this netTAP 50 device until we set the IP address again with the Ethernet setup utility. Look, I make a rescan and my netTAP comes back with the IP address 0. I'm setting it now back to the correct one. Right mouse click, set IP address. Here you go. Okay, and down in the corner you see the arrow here, and Ascii also says it has lost the connection. Ignore that. The IP address has been set already. Again, now we are fine. Now we can start to configure netTAP in details. Let us first of all start with the Ascii configuration. A right click to netTAP will open up this dialog. Here you find some basic settings. The serial interface you can choose, the baud rate, just some basic things. Here you see the most important window for Ascii. You can choose first of all the mode that Ascii shall work with. 4 modes are available. For my demo, I am using the send only mode. With this drop-down boxes you specify the Ascii sequence character set that shall be sent later on. For my Ascii stream in mind, I'm setting a start character of A. In the second drop-down box, I'm setting now the data that comes from Open Modbus later on of an unspecified length that will be replaced later by Ascii with the data that comes from Open Modbus. Finally, I'm setting an end character of a Z. In order to let Ascii send out something without my intervention, I'm setting a cycle time of 500 milliseconds. So this is pretty much it for Ascii. Okay. Now we make the settings for Open Modbus. Since I want to use Open Modbus as a server, which is set per default, there is not much to set here. I don't want to use DHCP, and this is why I'm entering now a fixed IP address and a gateway and the network mask. So this was all about Open Modbus. Now we go back to the gateway's main configuration page. After having configured the both protocols, we have now to set up the data mapping between both protocols. The dialog here shows you all data that is provided by each side. By highlighting data on one side and drag and drop it to the other, you can map data from one side to the other. So highlighting first and drag and drop it to the other side. So I'm mapping two words to the application handshake flag, to the data length from Ascii, and I take some words from Open Modbus and map it to the Ascii raw data. Then the opposite side, another handshake cell here, mapped to Open Modbus. Okay, and the error cells and registers, fine. So the result you find in this screen down below here, it shows you again which data is mapped from one side to the other. Okay, netTAP 50 is now configured and it is time for a download. So leave this window, right mouse click, download. Wait for the progress bar, and that's it. So now we can start our peripheral utilities like Hyperterminal or ModScan32. You see here I make another scan, and this time it hasn't forgotten its IP address. Look just into the diagnostics window. The LEDs are green and yellow. Firmware is working. Everything is fine after the download. Super. So we can leave Cycon.net now. We do not need it anymore. Now I'm opening up my Hyperterminal. Specify the COM port where I have connected the serial cable to. Set the correct baud rate. Say OK. And you see the results that I set up before for the Ascii protocol, sending an A and a Z at a cycle time of 500 milliseconds. And you see there is no character between the A and the C, and this is quite okay since I haven't set up anything via Open Modbus. As an Open Modbus client, I'm using ModScan32. You can get it from the web for free. I'm setting up the IP address, and you see it is now scanning and polling for the data in my netTAP. You can look to the holding registers and to the input registers as well. And I'm quite happy that I see the value 8 here in the first Open Modbus input register. And when you open up the manual that explains the Ascii handshake procedure, like I do here, you see in the handshake register, which is an unsigned 32, there is a bit that says netTAP and Ascii is ready initialized. 1, 2, 4, 8. Yes, the value 8. So looking to this bit indicates that netTAP is working fine. In order to start Ascii communication, we have to set 2 bits here in the holding register, which is a value CO, in order to enable transmitter and receiver of netTAP 50. netTAP 50 confirms in the input registers with the same set of bits. You see, C8. Okay, as next we want to pass over data to Ascii. And we do it with this structure. This is the handshake register. The length of data, which is mapped to these both modbus registers. Setting up the length, and finally the raw data. In my demo I just want to send one character. The character shall be an A, which is for 1. And finally, as explained in the manual, you have to toggle the handshake bit that is in the register we set before to the value CO, which results in a value C1 finally. Now let me bring hyperterminal to the front in order to see the immediate result when I press update. And now you see the sequence is A, A, Z, A, A, Z. We can add one more character by setting the length to 2 and changing the send data to, for example, 4142. And after the update, looking to the immediate result, toggling the bit C1 to CO, and you see BA, BA. So, dear audience, this was pretty much it. Thank you for your attention, and goodbye.